So it's a nice little example, I think, of just the idea that they have to collide. I've got two chemicals here, potassium iodide, that is upside down, potassium iodide, so Ki, and lead nitrate, PbNO3, lead nitrate. These guys will react in a double displacement reaction to make potassium iodide and, lead iodide and potassium nitrate. And so I'll put a little bit of solid potassium iodide in there. That's actually quite a bit. And a little bit of the lead nitrate. So I dumped them both in there together. Now, if I stir them around, you might be able to make out that there is a slight color change there. I don't know how well you can see that. I thought a black background is easier to see than a light one. Let me turn that lamp off. Yeah, you can see there's a little bit of color to that, right? Not a lot, but there is a little bit, but none before I stir it. And the more I stir it, I will get a little bit more color, but there's still not a whole lot, right? Because they have to collide. So as I stir them, I am helping them collide a little bit. But if I just add a few drops of water, watch it how vivid that is, right? A little bit of water really picks those things up and lets them move around a lot. So where that water hits, they're really able to collide a lot now, right? So I kind of mentioned it in the other video, but that's why we do so much of our stuff in high school chemistry dissolved in water. So many of its solutions, so those things can be slamming around and bumping into each other. Because as soon as the water hits it, it helps those things move around, right? The water is kind of like a catalyst here. It's not exactly the same as a catalyst, but it's helping because it's not a different pathway or anything. So it wouldn't technically fit the definition of a catalyst, but it is certainly helping our reaction so that it can move around a little bit better and that kind of stuff. Anyway, just a nice little example that I like that one because of the motion and that kind of thing.